Welcome to the Pac-Clone series of creating a Pac-Clone video game. This is sort of an in-between video, in between the last video that I did, which was Pac-Clone 5, and the final video, the final completed video where the game is actually 100% done, which I'm assuming it's going to take me some time. It's probably not going to be until early next year sometime. At any rate, I'm trying to work on the program at a lower pace than what I was doing originally, and I need to take time out to do other things rather than I need to play some games as opposed to trying to create this one. But in the meantime, I wanted to go over a few things that I've come across as I've been implementing some of the changes as I've gone forward. I've come across a couple of things, and I want to share that with you. This video is intended for aspiring programmers or people with a technical background, and I don't think anyone who doesn't have that sort of a background would really be interested in watching this video. This video contains spoilers. If you would rather not see some of the developments as I am going here, this video contains a few spoilers, so be forewarned and turn the video off at this point if you do not want to see those spoilers. It is a pretty technical video, and I'm sorry about that, but it is a video about creating a Pac-Clone video game, and I do cover techniques in assembly language and using the CBM Program Studio. So sit back and enjoy. Okay, so in this segment I'm going to talk about a little effect that I was trying to build into my version of this Pac-Clone, even though it doesn't really show up in any version I've ever seen. And that it was to make like a transition, one map draw into the other. And so I'll show you what I'm talking about here in a moment. I have this subroutine to draw the map, to draw the Pac-Man map on the screen. And then I have what I started with is a second routine that would draw, to redraw the map, but with a different map coming up from bottom to top. And let me run that to see, so you can see what it is that I'm talking about. So there it is. It's kind of slow, and I'll go over how that works really quick here. Let's see if I can get it down there. Let's run that again. What I did here is I have this program code. It's going one line at a time for 40 characters. Let's take the second line and then basically copy the second line, paste it into the line above it. And it does it all the way down to the bottom. Copy that bottom line, paste it in on the line right above it. But then at the very bottom, I have a quick little loop that draws in the new map and just replaces that bottom line, so that as it goes, it's painting something in. And right now it's the same map on this version. So I was trying to play with that, and then I came up with a different version of that. So why reinvent the wheel of the draw map? Just redrawing. Why not just redraw the map, but change the map pointer, the low and high, as you draw, and just call it over and over again. Seems highly inefficient, but I thought I'd give it a try. So I want to show you what that turns out looking like. So I'll comment out the other one and comment this one in. And you see I didn't bother yet to put this in a loop, so I just call it 25 times. And let's run that. Because one function called moves the screen once. one position, one row at a time. So you see, I don't know if you could tell on the video. Let me run that again. It's really jaggedy coming up. Again. It does this trick, you know, it draws, but even in emulation, it draws really quirky. But it's a more succinct and cleaner way of doing it. But because it's so jaggedy, I opted not to use that. And then I went ahead and redesigned and went with a fourth version I want to show you. Let me uncomment that. And before I run that, let's take a look at the code. And in this version, I figured, why not just copy from basically from the line, one line below. 428 is the second line, the second row on the screen, and then paste it in on the at 400, which is the top line on the map, and do the same thing with the color memory, which are these memory values, and then do it all for 255 times. Just loop it, and then doing that for 400, for 500, for 600, and for 700. This turns out to be really fast, a lot more faster than the other two methods. And as I'm going here, I'm doing the color values, you'll see here. And at the bottom, the same sort of thing where it has to bring in the new row for 40 characters. So at the very bottom of the screen here at 7C0, the last row out of the 25 rows on the Commodore 64, the last row, it's bringing in the color value and it's bringing in the data for 40 characters as it goes. And so let's see what that looks like. And you see it's much faster. It comes up, and I have my color values in there. And I've also, spoiler alert here, I've also changed the dot pattern a little bit. I was trying to make it such that it would, you could follow a certain, you could just follow the dots and clear the dots a little easier that way, rather than having to go into every little nook and corner of the whole map. And I might tweak it even further, but this is where I'm at right now with it. But let's run that again just to see how that looks. So, and this is full speed. There's I was thinking I was going to have to slow it down, but when it didn't have the color values in there, if I were to comment out all of the if I were to comment out these two lines, on all the color value areas, it runs a lot faster. So I thought I was going to have to throw a delay in, but the way it looks now, I like that speed. So I was thinking I would maybe have the effect going from down to up, and then maybe from up to down when you clear a map level. It was just an idea. I do plan on implementing that. I also had the idea of maybe throwing the effect in where it shakes, like moves up and down. It moves up and then down, just to make it look like, something happened. You ate all four monsters or whatever. But that was an idea I had. I don't know if I'm going to implement that. So that's it for this segment on the little effect of drawing the map in a different fashion. I do want to bring up the screen designer that's built into CBM Program Studio. This is a fantastic tool. You can either go into it from the tools menu and then to the screen editor, which will bring you into a blank palette, or you can open up the one that you've already designed and saved, which is down here on the bottom left under Screen Designs, which I'm going to pull up. And in here you have your colors right here. I'm defaulted into draw mode. And for example, if I were to go down to where the period is, or the dot, which is, I believe, character 46, and if I use the left mouse click anywhere on the screen, it draws a dot. If I use the right mouse click, it uses the erase color and it erases. So I can put in dots, erase them. But the thing that I noticed when I was doing that draw map function, I really wanted to know what these positions were. And as you move your mouse, you see on the bottom the base address down here, the base address, the character address. These values change as you move your mouse. So here at the bottom left corner, you can see where I got that DBC0 for the color value and the 7C0. So this is actually very useful. It helps me to determine where all the power pills are, the exact position, so I can just write those values down as I move the mouse, write it down, and record that information. And now that I've added a couple of maps, I'll show you what those look like so far, what I've worked on. Down here, it shows that I have 4 maps. I'll show a couple of those. If I hit next, you see the difference there. The color change. What I've decided to do was to keep for simplicity, just to keep the ghost cage in the same location and the warp tunnels in the same location. And then on the third map, it's the same as the second one. I do intend to probably change that. And the fourth map I'm going to leave for a surprise. But this is a very useful tool, and then I know I covered this in a prior video, but it's fun to me, and so I think it's cool to share that. When you go to export it, you hit export a similar file, export a similar, and what I've been doing now is exporting it not to a file, but just into memory, exporting the color data, and coming down here, adding the description, generating the empty rows, and generate the whole row including trailing spaces. When you do that, it generates this whole thing, and it puts comments on the screen with what you named your map. I named it map 1, map 2, map 3. So it's very useful, and it's very fun to design your screens this way. You also have the ability here to throw in your grid, which throws in those grid lines. And it's a highly useful tool, and I highly recommend it. It's very fun. I wish I would have had this tool back in the 80s or in the early 90s. This would have been really fun to play with, and it still is. It's a great tool. Okay, so in the previous segment I was talking about how cool the screen designer is. In this segment I wanted to talk about the Sprite Editor, which you can get to in CBM Program Studio from Tools, Sprite Editor, and you start off with a blank palette. Or you can go directly in to your your saved version of the Sprite Editor, where I have all my sprites, and you can see here I'm up to 31 sprites, which is a lot, but the reason is for the animation. So you can see I have my up facing, my downward facing, left facing, right facing, and then I have the ghosts. I'll expand them here as I go. And what I was trying to get at, and I still haven't removed the frown yet. I don't know if I will. So lower on the list of priorities for this program. So I needed a death animation. And that's what I did. I directly ripped off or copied the way they do it on Pac-Man. So when you die, no matter which direction you're facing, they put you to facing up, and then you slowly kind of deteriorate as the music plays. So that's my little animation. I'll show you what that looks like. If we run this from 21 to 31 down here, just put it in on the animation, 21 to 31. That's kind of what it looks like. So, slow that down a little. And it looks a little different than Pac-Man. This is only 8x8 grid, so this is what I had to work with. So, and this is a very, very useful tool, this Sprite Editor, and it's terrific to use. So in the same way you can export your screen data, you can also export your sprite data by going up here, File, Export to Preview. Assembly data, generate using three values per line. Pad your data to 64 bytes, decimal or hexadecimal. And then generate only included sprites or all sprites. So there's a checkbox for that, include in generation right here. So if you uncheck that, it won't export as part of this. And then you can just copy that to the clipboard, paste it into your program, and you're off and running. So that's where I'm at with animating the Pac-Clone death. So in this segment, I wanted to talk about a method of creating a sound effect that I stumbled across. I believe I saw it on Lemon64. It was on a forum or one of the posts that someone created and said, just start off with these two lines of code, and it was an LDA and an STA. LDA, a number, store it in 54296, and then load a 0, store it into 54296, which even now I don't even know what that does, but I'm going to go into that in a minute. What this does is this creates a sound and then it turns it off. And then if you don't throw a delay in between, then you don't hear anything. Then it's just no effect. So what I decided was to try to put this effect in as you're eating the dots. And so I'm going to show you what that sounds like. And for now, until I get something better, and this is all, I know nothing about sound effects. This is the effect I'm going to use until I have something better. I did stumble across a website, which is a Commodore 64 memory map. And in here, 54296 is D418. So let's look for that. Let me make sure. D418, yeah. Volume and filter modes. So this is the memory map. This little memory map is very useful. It shows you all of the where the things are mapped into memory on the Commodore 64, and it can come in handy, and it has a lot for me already. So enough about that. Let me run this. You're going to notice that I've implemented the flashing energizers once I run this. But that's pretty much all you're going to see. And the sound effect. Here it comes. I thought it was better than nothing. But I'm not 100% satisfied with it. I just wanted to show you how I created that sound effect. If you want, I'll show you a death. What my animation looks like in game. Check this out. Boom. Alright, so that's the sound effect. You saw the flashing power energizers and the death animation in effect. In this segment, I wanted to go back to a discussion that I had a little bit in the last video regarding program interrupts. I got myself into a little bit of trouble using the interrupt, and you might be saying, like, how can you get in trouble using using interrupts? Well, you can get into trouble with your interrupt if your main program ends up stepping on things that your interrupt is using and vice versa. So that's exactly what happened with my interrupt. As I was making the energizers flash, they're using the zero page memory, FD and FE, but I was also using FD and FE inside the main program. I use it for things such as drawing the map. So right here, FB, I'm using it, I've since switched it to FB and FC across the board, and that's why this is a little more expanded, or a little, it's much more succinct if I was able to use the way it was before when I had FB, FC, FD, FE. But because the interrupt was also using these same variables, what would happen was just some weird things, like in between levels, the colors would just go all wacky. You could be going along, eating the dots, and then the dot wouldn't erase. It would just stay there, but it would be counted as, and you would get points for it. So just weird little quirky things like that. And so I wanted to throw that caution out there when you're using interrupt, to be careful not to step on your main program data. And I know it's more of a complex issue, but when you're using these variables, FB, FC, and you're using that in your main program, but you're also using FB and FC, for example, in your interrupt, then they continuously get updated in the background while the program's running, and so you'd end up with kind of random data. And that could be a problem, and it's a word of caution.